There will be the Facebook group. So มี Facebook group อยู่ right? It's recorded. How do I make it full screen? Don't know that. Should be about here. Customize people only. Focus on content. Okay. All right. Just 3 minutes. There are 65, if I remember correctly. Though that is the latest number of registered students. So there are quite a lot of people here. You can opt to study online. I already put the link into LVB2. You can access that via LVB2. But if you want to come to the classes, then you're welcome, right? Because I think a lot of time engaging, well, when you ask questions, if you have questions, you want certain discussion, you can do it here. And it's better than doing it lazily at home. Because studying while sleeping, while laying down, it would not really help you learn. Right? That means being with your friends sometimes helps. Okay. I think that's like the thing we learned through COVID. Right? That flexibility sometimes does not really create environment for concentration, right? For learning concentration. Ideally, it's funny though, because it should be ideal, right? You can concentrate because you are at the place that no one could disturb you, but in reality, is that that place is for play and sleep, so no work. That means that is rather difficult concentration. Never mind. Okay, so I also record the video here. I should be posting that to the Facebook group. I already created the Facebook group. I should upload that right now. Upload the syllabus so you can access the syllabus and also all of the link and also the Facebook group there. Let me post this to the learning activity. Okay. I'm posting it right now to the learning activities. Okay, now if you access, if you now access LEB2, you will see both the slide for today and also the syllabus in the LEB2. I can share that a bit here. What is here? You can just go to learning activities, and I already list all the topics that will be covered in this course, starting with today, and there are 2 files here. If you do not have that, if you don't have the access to LEB2 or whatever the case, you can ask your file from your friend here. And in the file, there will be multiple links. Here in the files, you will see that that is my email. There is the Facebook group, which you can click and then join the group. I think I have to approve that though, to just click and join. When I have time, I will set the automation in approval. And then that's the link to Microsoft Teams, which is also accessible in LEB2. Okay. Just in case that you cannot access that right now, I can share this file to you, or you can ask your friends, any people here in the room, to send the file to you. There are 2 places here, 5 over there, plenty scattered around the room. Okay. Let me put it this way. At first, I only planned it to opening this course for undergrad students and focusing more on the implementation side. But I supposed to have certain elective for the grad student as well. And because of the duties, the management duties, I really can't have any more courses. Right? And so that's the reason that we have like the combined sections here. Right? Well, it may be good. You will be able to both learn implementation side and also the mathematical theoretical part as well, both of these. Okay, and so let's start. Welcome to the generative AI course. I'll be actually this topic has been added to the machine learning, to the deep learning courses as the part of the thing that should be like future study. I think only in this semester that I kind of spin off that from the, usually this will be in the deep learning. I used to teach deep learning for the master degree student, and it would be so for the next semester. We focus on more on the theoretical architecture of the deep learning neural network, right? Different types of that. But for this one, we will just look at the architectures that are directly related to generative AI. So ideally, it would be starting first from the deep learning and then coming to this one. Right? But whatever, right? Let's learn whatever we have here. Okay, so why are you here? Right? There are so many interests, right, in generative AI, and that's probably because of the global trend and the rise of generative AI technology that we have seen in the past just 3 years or so, right? Starting from ChatGPT, starting from the OpenAI movement. Actually, it began earlier than that. I taught deep learning, I think, back in 2018, and there were a number of senior projects, not senior, number of term projects that dealt with generative adversarial, right? The use of the generative model in order to make the model become better. So we have seen like the rise of the use in AI. The adoption of AI has been increased, and the use of generative AI starting from just here 2023, right? Before that, are there any generative AI? Yes, there are plenties. Right? There are plenties. The technique of sampling in statistics can be thought of as the starting point of generative AI. Generative AI right now, we are working with model. The model can generate something, right, based on the condition that you provide the model. If we were to go back like 10, 20 years ago, there are already such a model, like in simulation modeling, like in statistical modeling, that you can sampling from distribution and get certain samples out of that. Right? There are techniques like SMORT, right, to boost up number of samples using similar technique to this one. Right? But well, right now, this is the trend. And it's one of the discipline actually that has been like quite popular in the past two years, right? So when we think about generative, in a sense, a generative model, there must be a certain distinction. Just like when we think about AI, right? If we were to think about years 2010, 2020, the word AI would refer to something like machine learning, right? Using text analytics, computer vision, right? Using machine learning in different work. If we were to talk about AI back in 1990 to 2000, that would be a reasoning system. Right? So that means AI has been evolving throughout the years. Right? When you have more computation, better mathematics, better computing device. But still, there are use cases that would be suitable for generative AI, which you will see in this course, and also some that would still be suitable with traditional AI. Right? Why would we use generative AI to do search? We wouldn't. Right? There is search algorithm. Just use the search algorithm. Why would you use generative AI with the sorting? It was really funny. I think last year, the beginning of last year, there was a study. There was a study on the trend of generative AI around the world. So I took a look at the report and saw that a lot of things that mentioned in the report is actually traditional AI. They are talking about being able to do classification, regression, clustering, and all those things as part of the generative AI. So be aware of that, right? So the hype come, the hype go, technology stays, okay? So traditional AI involved with making decision. You create a system that reduce data rate. Think about it this way. Traditional AI back then, you have a bunch of data rate, and you try to reduce those data rate to be just some variables. Right? Like in machine learning classification model, you have data set, images, text, customer data, and then you predict class. Right? Whether the customer whether what type of image customer posts, or whether the customer would perform certain action or not. Right? We saw that in the predictive analytics and like fraud detection, recommendation, author use cases. Those are for the traditional AI. Just 5 years ago, that's not traditional. That's modern machine learning. Or even right now, if I were to sell a project to a company to do, say, fraud detection or customer prediction, it would still be this AI, machine learning things, right? Not the generative one. Because we are still figuring out here. There are still some unknown, some randomness. You will see that in the course when you train your own model, right? And then you have the generative AI. This allows us to generate content, generate art, do style transfer, automate content for moderation. Right, talking about this, like I got one student, master student, that did the thesis with me. I think it was 2018. Right? Back then, he really wanted to do this style transfer, like transfer Van Gogh style to some other images. It was quite trendy, right, at that time. You know, like just 4 years passed, then everything is here already. 4 or 5 years passed, everything is here already. That thesis is already outdated. So it moves very fast. Like content generation, content moderation. So you see that there is a shift, right? Shifting from having AI to be the filter, to be the prediction system, to be human, to generate, to initialize, and then having AI to generate content for us. Right, we still define things that we will cover in this course, okay? So this course will be about generative AI, but it will not be really using big model to train whatever, because otherwise you will not have computer to do so. You probably need compute resource for that. So generative in this sense, generative doesn't mean retrieve. So when we talk about generative AI, it's not retrieving or search documents, which is part of AI, research engine. We are not ranking document. We are not performing recommendation. Those are traditional AI. We are not talking about making decision, which is the core part of machine learning, that you train the system to decide based on pattern using, say, Bayes, random forest, gradient boosting, CNN, RNN, RSTM to perform prediction. So that would be making decision. And we are also not using generative AI to group. So what are we using it for? Right? For generation, right? For generating. We need to have it to be able to, it must be able to create some patterns, right? Create some patterns that the model remember. Okay, so that means it should be able to generate or regenerate existing pattern that it is trained. But because in real life there are plenties of patterns, that means you cannot really let it just remember one. Just like the speech that when you talk to one another or when you hear the voice, right? There are certain variations. Some of those will come from the physical constraints, like the size of body, the vocal fold, whatever. The others would come from the style that person used. Right? So there are certainly variations or uncertainty, which in mathematics will be described as probabilistic. And when you see the word create, mathematically create means sampling. You're just sampling thing out from the distribution. So that means generative AI will be about statistics. It will be about distribution. It will be about deep learning, machine learning. And not reducing data rate, but trying to represent it somehow so that you would capture the uncertainty. So these are generative model. Okay, and we will see later on, right? For text, you see chatbot. Well, right now there are plenty chatbot out there. In vision, computer vision, we have image generation, use it for editing. In audio, generate music, speech. In multimodal, you have multiple pulled together to create a model. We will explore, I think, for the ease of study here, we will probably explore mainly on the text and image, because those are the sources of data that are easy to find. Speech and music is fine. If you want to do a project about that, it's okay. Text to image, we'll probably delve into that a little bit. Video will be difficult though, because you need to have quite a computational power in order to, say, compress the spatial temporal data, the video data, and then use it to train. Right. So you will see that need to have quite a bit of GPU. You can definitely use Colab in some of the lab that we used here. We'll try to make it not so big, but in your project, maybe you need to pay. Sometimes you have to pay in order to play. Right. Okay. Okay. That the department also have some some of the GPU that you can use, but it won't be enough for everyone to use that. right? And for the lab, you don't need them, right? But if you want to do like computationally complex project, then you probably need that. Okay. We see generative AI tools right now, generative AI technology, that have been integrated with existing tools. Right? We see something like in Photoshop, when you create when you try to edit the software, you do it manually, right? For generative AI, like in Midjourney right now, put something in and then let it generate the rest. What are the pros and cons in this tool then? Would people often say that AI will replace things? I haven't seen that happening yet. Ever since back then, I haven't seen any AI replacing any technology at all. It just enhance and make it do more, yeah, and that. And people still taking photo using mirrorless camera, right? People still doing things in analog way because sometimes that is, you have finer resolution in the real world. A lot of times you have finer resolution, both in terms of making decision, control, and many other things. While here you need certain restriction in terms of the resolution that you can deal with it. In Photoshop, right? If you want to edit the picture, well, if you are very capable, you can make it very beautiful, right? Using the tools there, adjusting dynamic range, adjusting contrast and others, and the band. For the generative AI, you can put the two images together and let it generate a new one. And or you can just describe things and then it generates something onto that, right? So that's cool. But sometimes it's really hard to control though. And you see, it's funny that I saw some of the big names in the market, right? They decided to jump in the bandwagon of generative AI and create an app that contain distorted font. That's really like, it likes a high-end brand want to play with this thing, but doing ad in the low quality way. Right? Because when you use Gen AI right now, there are still problems with the text in the AI. So if you use that, it's kind of create a distortion in there. Right. So there are also limitations in generative AI. Most of the time, you see that when you use ChatGPT, use a lot of things, it generates something out, but it's not really factual. I try playing with that one. I asked the Gen AI, ChatGPT Gemini, to help me setting up server from scratch. It took me the whole day because there were a lot of errors along the way. Like, oh, it forgot to tell me to include this term, or some of that already depreciated, and then it's very difficult to kind of switch back and forth. So it's quite fun. It can answer anything, but it's not factual. There are still problems in that. Impressive, but brittle. Most of the time it's quite impressive in terms of result, but it contains lots of fault, right? And there are like balance between creativity that it creates and reliability that you can use it in real life. So there are those limitations right now, which are still the gap that has been filled. Okay. So for today's lecture, I wouldn't go too deep, right? We will cover these topics. Right? We will cover the course introduction. Right? Let's see what you learn here, and maybe you can decide whether you want to drop the course or still continue with it. Just some of the master students. You were with me last semester in the reinforcement learning. Yeah, so mathematics-wise, this is quite similar to that. So despite the name, I used the book, I think it's Generative AI with PyTorch as a reference, but that is as far as it goes. Only for the code reference, because it contains less mathematics. That means I have to draw mathematics from the paper. And just in the first lecture here, you see a bunch of references to, I think, those are the papers that change the world. Some of them are the one that got someone the Nobel Prize, Professor Hinton. Right, so you can take a look at them. Okay, so let's see first the introduction. So these are the course learning outcome. After this elective course, you should be able to first explain means understand. You should understand fundamental principle of generative AI, the architecture, why it arranged that way, and maybe able to extend further from that. Right? So understand principle. And then second, you should be able to design, implement generative model, generative AI model, simple one, generative AI model using the proper tool, PyTorch, using proper model in that. And then know the evaluation metrics for generative AI technologies. Also limitation, impact, and so on. Okay, here is the meat. The grading will be done through the work here. The first part is the lab and homework, that's 30%. There are 12 of them, right? But I will count only 10. That means you can miss 2, right, from the 12. Okay? So usually in each lecture, there will be the code accompanying the lecture, which some of them are drawn from the book that I mentioned. But the exercise will be added on that. Right? I would ask you to do something more, right, based on the model that you created so far. Right? So that will be the homework in the lab. And then the project here is 30%. Project is team project, right? Working in group. So how many people per group you think should be suitable here? Then it means if you fail for the whole class, well, that would be problematic. The work has to be increased proportionally with the number of people. So how about, since we have 60, right? But 6 is too much. Okay, we have TA as well, Superwit in the back. He'll be TA because there are too many of you for me to grade the homework. So Superwit, he is the PhD student working on representation learning, right? Something, the topic that is quite similar to what we will learn here. So how many per group? What do you think? 4? 5? Individually? Okay. But well, let's put it this way. For the undergrad, 5 per group. Okay. For the grad student, at least 2, I think. 2 per group, right, for the grad. Well, 5 per group for you guys would be 10 groups already. For exchange student too. Or 5. If 5, it means that all of you are just in 6. Then 3. Then 2 or 3, whatever, right? Per group. But you can mix, right? You can mix with the student here if you want, right? that would make 5, right? Okay, for the grad student, 2, right? Only a pair, okay. But some lab will be individual. For example, for the next lab on PyTorch, it will be individual work. But for the later on, like in the DC GAN, deep conventional GAN, you can talk to one another to understand things, to design things, and whatever. And for the project as well, for the project as well, it should be 5 for undergrad and 2 for grad. Okay. I expect for graduate students should delve into a little bit more in terms of research, uh, putting some author paper, architecture, and try it out. Maybe you can find some idea in your in this course to help you in your thesis. And for the final exam, 40%, right? Uh, right. In this type of structure, usually whether you get good grade or bad grade depends on the work, right, the above work. If you submit the work accordingly, usually you should get good grade. But if you submit, say, 5 out of 10, that's difficult for me, right? Okay, let's move on then. Here are the topics that will be covered. This week, we will look at the generative AI principle in general. Okay, that means we will look at the overview, some of the paper, historical perspective of historical, it's fun, right? The history of generative AI, we'll look at that. And then for next week, we will study PyTorch. Some of you may already be fluent with PyTorch, so you can, if you decide to just skip the class and then do the lab only, that's fine by me. I don't have any problem. You can catch up with the video, right? Otherwise, you can be here. And then afterward, here the generative adversarial networks, and then advanced GAN. For the advanced GAN, we will look at conditional GAN, cycle GAN, style GAN, right? So different types of GAN architecture. And then afterward, the VAE autoencoder and variational autoencoders. One of the, I think this is the pinnacle of generative AI would be on the GAN, starting with GAN. And then you have latent representation in VAE. Learn from the latent representation in VAE, we have something like the sequence model that you can create a generative model using simple machine learning, right? Deep learning, RNSTM, and then go further to the transformer-based sequence generation, right? So that would be like traditional model, RNN and LSTM. Then when we move to attention, move to transformer-based sequence generation, we have the GPT approach, the generative pre-train, and using attention in that. Actually, in the original paper, it has already proposed the transformer architecture that have partly the decoder part and encoder part. Right? And for the decoder part, you have something akin to the current GPT architecture. Then in the next one would be a topic of fine tuning, right? At least fine tuning a very simple model. The topic in this topic, it will include some of the thing that is also called adapters. Right? You kind of attach this to the main model, and then you have additional learning capabilities or additional patterns that the model can be adapted to. Then in the next two lectures, even though I separate them like this, these are diffusion 1 and diffusion 2. Right? So diffusion 1 will be learning about noise, denoise. Those are the original step of the diffusion model. And then going to the latent representation, stable diffusion technique. Then moving forward to visual language model, doing text to image generation, and then moving forward to engineering, ethics, and then that's all. So as you can see from the topic here, we cannot, even though these are already in depth, we cannot really go into in depth our topics. We kind of jump around the places. Right? These are all about generative AI, right? But we kind of jump from one topic to another. Just having one lecture with conditional GAN, cycle GAN, and whatever GAN that we don't have enough time. Right? You wouldn't have enough time to cover everything. Okay. So these are the topics. And then we will have project presentation on the 18th of May, which is which coincide with the senior project presentation for the 4th year, right? There are plenty of 4th year here. Right? So we have, you know, right, that the 18th of May is the project presentation day. You did know? Yeah, that will be the final exam for the senior project this day. And it coincides with this as well. So you can have senior project presentation on the day and then term project presentation at night. And then week afterward, we have the final exam for this one. Right, so these are the whole, the list of the thing. However, because I also have like the management duties for the department, I'm not really sure. Oh, it's in at night, I know, but I'm not really sure whether I will have to travel on each of these day or not. And you can see that I already jam-packed everything together. Hopefully we don't have to cut something out though. And even though we already have enough of the slot to cover, but at least we can have like 10 lecture slot here with 2 in the spare somehow. So let that be in the future. For the lab, each lecture will have lab. You have 1 week for each lab to submit the work. So you need to submit it within, although I put it 5 days, I put it 7 days. Right? So you should submit before the class. And the project, at first I put it as the generic template that I use, the team of 4, but 5 is fine. There are too many people than I expected. For the undergrad, 5 is fine. For grad student, 2, for a pair of you should work together. And that applies for the project as well. And for the project, they will be evaluated accordingly. You need to present and write up a report. Write up a report about the work that you did and submit it on the day of presentation. So the topic of the project should be related to generative AI. That means you can take any one of the topic and then apply to your study, or you can move, do something further than the class, like you want to use existing model and do whatever thing that you want there. But if you use like the state-of-the-art model that you can find right now in the market, there are plenty of techniques that have already been applied. Like the model contains both diffusion and VAE together inside. So what are you going to do next, right? I think about that. The project can be something that use a small data set. When you think about generative model, it doesn't have to be image. It can be anything. It can be customer data. It can be financial data. It can be anything that you want. That you have data to play with, right? So let's take a look at. So those are the course introduction. Do you have any questions about this first? Any questions about either the project or the topic here? Like I said, I will try to finish things before 25th of May. Right? That means if some of these class need to be dropped, it will be combined with subsequent one. For example, I think 16th of March. 16th of March here, I have to go with the Faculty of Engineering to another country. I think I'm not sure yet, but I might have to. Let's see if that's happening. All right, so let's look at the intro, then we can call it a night, right? So generative AI, you have a model that trying to make use of data, and then make decision or reduce the data to some values. If we are talking about numerical values, then you have regression model, class values, you have like a class, then you have classification model. So depending on the thing that you want to do, if you train the model without examples, using unsupervised learning, you have class as well, but without training, right? So that's discriminative model, right? The model that try to classify or reduce the data rate, reductionism type model. And on the other hand, you have generative model. Generative model work in the other way around. During training, it may be trained based on certain data for sure, but when you use it to generate that type of data back to do whatever the thing that you want to do. Mathematically, if you look at discriminative model, you have a model that tries to learn P of y given x. Y is the class, the output, and x refers to input. Okay, we are trying to learn this probability of y given x, which can be represented as the logic, formula, or depending on what type of model that you use, right, in that. For the regression, y would be the mean value. X would mean feature vector. For classification, you have y as class, and x would be feature as well. And then you have like the probability of that class. Okay, and then what the algorithm try to do is to draw decision boundaries, try to separate the data into the two groups by maybe drawing a straight line in logistic regression or drawing a very complicated lines if we use, say, deep learning. You know, for deep learning, the thing that differentiates deep learning from the shallow learning would be the domain transformation. That is the linkage between x and y that you see above. It's not just a simple line like that, but the data will be transformed into another domain and then transformed to another domain. That would be better differentiate one from another. Right? The easiest way to think about that is to think about the technique like support vector machine, that you have kernel function transform a group of data into another plane like that. So if you already take machine learning, and that would be like part of the basic machine learning thing that like in SVM. So discriminative model will discriminate data, will classify or reduce the loss, either that would be regression loss, classification loss, or variation loss. Okay, so it would be like that, my cat, right? And ask if this is a cat, then you get the answer yes or no, right? Okay. So from image data, you have yes or no. But in the generative model, right, you are not really training it to reduce data rate, but you let the model represent data. That means the model will need to be able to generate back the data rate that it originally learned. Right? It has to learn the distribution of data and then sampling from it based on certain condition and generate the result. I generate this from the tools, right? This is not a real picture. Cute though. And then you can see the architecture would be different. For for the model that try to classify data, you would have the model that reduce from a higher rate to the lower rate and then reduce it to just one variable. But for generative model, you would have two parts, right? The encoder part and the decoder part. And the encoder part would need to reduce the data rate to certain representation, and the decoder part would have to decode it out, generate it out to be the same rate. So this is a really old concept in autoencoder, but have been adapted to today's model, like the UNet model. that has been quite widely used there. So now you can see that in terms of the representation itself, one would be the probabilistic representation that would reduce data, right? You're trying to predict, trying to do the conditional probability, predicting variable. But this one, the model itself is created to remember the pattern. And then you subject it to certain condition to do things that you want. Okay, so there are certain like pros and cons and good and bad for descriptive and generative. Both are still usable. For descriptive model, it's quite accurate though. It's not right. Not accurate, accurate. Right? This is wrong. It's accurate and efficient. You need problem in the limited scope. And then you would perform like prediction and grouping. For generative model, the model would be more flexible. Remember the pattern. You can apply it to do whatever you want. You can even use that to do the discriminative model. You can fine tune the model. I think it was back in around 2016, 17, that it is quite a trend that you use VGG, ResNet, and then cut I will say the head, right? The part that produces the output from that model and plug it into whatever you want, right? So usually this is called transfer learning back then, not yet generative AI. Transfer knowledge from one type to another. Right now you have like pre-train, and that pre-train can be applied to do many things. You can do classification as well, right? From the pre-train. Flexible, but it can hallucinate because you try to sampling. You can use it to do simulation, synthesis, and others. So those are distinctions between the two. Hopefully you now get the picture of what this code will be about. So let's look at the taxonomy though. Taxonomy means classification of generative model. Right? There are a formal one, but I'm not going to use that. Right? But we'll take a look. The formal one is quite complicated. And the one that kind of make it out till today. So that depends on assumptions, the basic assumptions of the model, depend on the strength of the technique and on the failure mode, on different type of fail on different way. So let's put it this way that we are going to classify it to only 4 types, and we will cover them for all the 4 types in the lectures. The first one is the GAN-based model, generative adversarial network-based model that use generator and discriminator. This is like the starting point of generative AI. We learn about that. And then there are, after that, VAE is a good example to learn a generative model that learn latent representation. What is latent representation? Think about when we, in the recommendation engine, right? One of the strongest technique in recommender system is SVD, right? The singular value decomposition, which decompose the transaction from user movie into latent representation, into the vector that represent the concept. Right? So this is the same thing. When we talk about, when in your, I think, second year, right, undergrad, you learn about linear algebra. In linear algebra, you learn about eigenvector, right? And later on, you learn about PCA, principal component analysis. Those are the techniques that allow you to retrieve the core vector, latent variable of the data out. So VAE, something like that. VAE will actually model latent variable space. We look at that. Then we look at autoregressive model, especially the sequence-based model. The reason that Professor Lacan, Jan, that say that it will not work because it's autoregressive. What does it mean by autoregressive? It means it's learn from something and then reduce regression, right, on itself, right, to be something that that can understand the pattern. So we look at that. And then lastly will be diffusion model. So these are like different style of generative model that right now that are in the market, are in research right now. if you ask me what would be the next from this, I think we are still stuck with this for now. People try to apply different technique to this, right? Creating multimodal, polymodals, multiple mode, complicated architecture, and they still rely on this. But if you look at the paper, there's a paper called Taxonomy of Generative AI, I think, this one, right, which define taxonomy based on the mathematical construct mostly, like whether that explicit density or implicit density, the density function that the model capture, whether it is represented explicitly or encoded in the model, and whether you have approximate density or the tractable density, right? That kind of have a way to explicitly model, right? Or you can have approximate density that approximate it out. And for implicit density, there are like direct method like GAN to estimate the density directly, and Markov chain, which allow you, if you, allow you to do simulation. Right? Markov chain represent certain relationship. You can look at the archive paper here to see more on the classification here. But for us in this course, we will probably look at these 4 classification, which if you look at that, it would be representing different part of the whole structures in this. Okay, this is generative adversarial. You have 2 networks. One would act as generator, and one would act as discriminator, and use game theoretic, meaning game theory style training model to let the 2 compete. Right? Generator objective is to generate the output that is close, that would fool discriminator. Discriminator goal is to detect fake or real image here. So by having the 2 compete with one another, you have quite high level, high quality output here in terms of the output. Okay, so this is GAN, right? We learn about GAN and build simple GAN model using the basic GAN, using some simpler data set. The good thing about GAN, right? There are pros. The pros of GANs are you have sharp images, right? You can do style transfer. And then the weakness would be the GAN is quite unstable, not stable. And then it also need to have 2 networks, which require quite a number of computational costs and constraints. Okay, I put it here, the link to the discussion on pro and con of GAN, if you want to look at that. That's the first one. So look at GAN. Well, you have 2 models. This one has to remember, right? Because this input is noise. It has to generate something out of noise. And that means it has to remember how to produce the data that could fool a discriminator. Okay. The next type is VAE, variable autoencoder. The above is autoencoder. Autoencoder is quite old. You have encoder, latent space, and decoder. Here, encoder and decoder. And this block represent the network. Like you have a large feed forward, right? Feed forward style usually for the autoencoder that reduce the number of nodes on each layer until you get like the representation here, and then the decoder would increase. And in the training, you would use the same data on both ends. So the network would learn how to represent itself. This has been used to do denoising, right? To do the denoising back then in just normal deep learning application. But it turns out This has been like one of the starting point of latent representation here. The variational autoencoder. That is, instead of just encoding it out, you kind of represent the encoding part as variable that can be combined in the latent space. And also you have decoder that produce back. Right, so, yes. ครับ I heard some said that you cannot catch up, right? This is still introduction. Right? We will have plenty of time to cover the detail, right? So I'll just keep it. So you have like latent space represent here. When you see the word latent, it means hidden. That means the thing that you are trying to understand are hidden inside the network. So it's not the surface representation, but it hides inside that. And in order to understand VAE, right, there is a math concept called KL divergence. Have you seen this math before? This one is quite important in machine learning in general, the KL divergence. And even for just a simple machine learning, a number of techniques relies on KL divergence to get it optimized. Right? We will talk about that later on, right? But we will probably not go into that much of the detail because it's not deep learning course. Right? So the VAE has to balance between reconstruction to be able to reconstruct the same data and to group the data that have the same pattern together. That's the KL divergence inside the latent space. Okay, so mode separation, separate data into mode. Okay, VAE is good to perform representation learning. It's good because it has latent space that the data, once compressed, would be at the domain that it's separate based on certain pattern. Think about word embedding. You know word embedding? In text classification, right? In word to vector. That you convert from the word into a certain vector. And then from that domain, it can group better if you have the same theme. That is very similar to the representation we talk about here. Inside here, the thing that belong to the same mode, the vector, should be expressing in the same pattern. But instead of just having a certain vector here, you have more of the representation in terms of the mathematical distribution. It's good this is good for scientific data. If you look at a number of studies in the scientific world, it has used a lot of this VAE technique. Because it can preserve the structure. Okay, but in terms of the weakness, is that it will often fail to generate the sharp edge and texture, right? And also to create like high fidelity image. And if you want photorealism, sometimes the GAN and diffusion can do better. We just looking at the model alone. But in terms of the structure, this is one of the good things. You can look at the paper here as well. I think this is like the original paper on, I think I put here the original paper on VAE. Oh no, this is the introduction on variational autoencoder. You can take a look at the link there. Next is autoregressive model, right? Autoregressive model would separate the joint probability, right? Factorize the joint probability, and then perform token by token generation. We have like in here the word generation that take in the previous, like predicting what would be the next word, right? So you can see that I think it has been explained a lot in for the ChatGPT, for the technique that is used in the generative model right now. But there is also this, the pixel CNN. Pixel CNN use the surrounding pixel to predict the middle one, and to predict what should be the middle one, and then train it as also as a foundation model, regressive, autoregressive model. Okay. I think one of the model in remote sensing, I think it's called vision transformer from sort. So do something like that, right? Taking in the patch, the block from surrounding block to predict the middle block, right? So doing something like this pixel CNN. That's the autoregressive. For diffusion model, right? The technique would play with noise. So add noise and then denoise. Right? So the technique contains a two-step to denoise the data until you get the final output. Okay, this is the architecture of stable diffusion. You can see that inside it contains the transformer style model. You have K, V, and Q, and reducing in terms of data rate. Right? And then there are steps in denoising, right? That is used in this type of model. Right? It works because it's quite stable in training and can produce the high quality image. So here are some state of the art. I took some these from the papers, some these from the website. I think this is like the latest one, the Quen image here. Quen image is the combination of diffusion and VAE. The flux one, this is diffusion. Cell diffusion XL, diffusion model. These are the links to the papers. If you look at like the website, it contains only like, do you want to use the API they provide? You buy something, then you can use them. But well, dig them out, you can find the original paper. I think the one that this is flux context or flux one, I don't remember though. But this is for the stable diffusion paper, right? Let's see. But that one is definitely from Quen image. The paper is called Quen image. Right, this is SD edit, guided image synthesis by editing. Might not be the original one though. Not sure why I put it here. Okay, some of the summary here of pros and cons, but all of these are still being used in the field. Okay, in terms of the sample qualities that it generates out, you can see that diffusion model would be one of the top, and it has been used in a lot of like modern hobby site, right, in performing generative AI, right, the diffusion model. But for the authors, these are not used alone, but it has been integrated to the diffusion, like combination of both to make it work. Like what you see in the Quen image, like combining VAE together with diffusion. A lot of technique also do that in that. So training stability for GAN is quite low. We see that when we train our own GAN, and VAE and autoregressives are fine. Right? We'll see that as well later. Stable diffusion is one of the best, although you require quite. The problem would be here. It is low. It means it requires a lot of computational power, right, to train that model. But for GAN, for VAE, this is quite fast. You can see when we learn doing the work in GAN, in VAE, we can train that from scratch ourselves. But the latter model, this is difficult, especially if you want high quality synthesis result. Autoregressive is okay. But still, if you say train RN model, you have to train it for quite some time until it kind of remember the pattern. It's still gibberish in terms of the result. Okay, in terms of the this is like summary sample quality for GAN. And the problem would be in terms of the model collapse and stability. VAE would be blurry output, over-regularized output. Autoregressive would be slow inference, early accumulation through the network. And diffusion would be high computational cost. So these are like the downside of each. But we kind of brute force it out with the diffusion model. That's why RAM are so expensive right now, right? RAM GPUs are very expensive because of cat pictures, right? So what goods are they, right? So in terms of concept exploration, if you want to say let the model capture the pattern and then generate the pattern out, doing some type of simulation exploration, that will be VAE. Scientific simulation, VAE diffusion, allow you to do that. You don't have to think about image all the way. You can do something like smart structure generation, generate molecular structure, generate whatever pattern out of that. So there are quite a number of things. Generate the root. Quite fancy different type of data that you can do. Or I think I proposed this to the company once. You can generate customer. If you have enough customer data, right? Generate the click virtual customer that would kind of perform independently. Think about it as a game. Generate the customer games that you can simulate customer, and then you might be able to sell that to company. A lot of company would try to avoid using the real customer data to use generated data, but you need customer data to train the model. So, but I think there was a topic in there was a topic in what is the research company? Gartner, right? In Gartner last year, right? Last year Gartner proposed that one of the trend in AI would be customer digital twin. Okay. And what is that? Generative AI as customer. That's customer digital twin. But we are not that far yet in representing human behavior. Okay. Okay, high quality generation, you have diffusion, real-time system, probably GANs and others. Right? Maybe if you want to use, say, last semester that you learned about building an agent, reinforcement learning, doing decision, right? In order to, say, incorporate with the generative model, is something that be able to react fast. So some of that would be here. Large scale text system, we see autoregressive model already, and foundational model would be transformer plus diffusion right now. Okay, I think this is the last one. Let's look at the historical perspective, history of generative AI. So when do you think is the starting point of all of this? We need to look at AI first, right? I think this is like the picture that has been posted around the internet for a long time. And the starting point has always been pointed out back to the proposal of neuron or the weighted sum. The neuron, representation of neuron, this is 1940. And then in 1957, the proposal of perceptron by Rosenblatt. Back then, I think at this time there were a hype in AI. Right? Once we have like perceptron, there were a hype in AI, a hype that computer we will have robot. You can see that in the movies. You can see that in Hollywood movies that during the year 1960, 1970, there are a bunch of futuristic robot movies that talk about automated robot back then, right? 60, 70. Right? And then enter the dark age, the dark age of AI because, well, it can just do XOR. What else? um, but in reality, there is still research that has been done during this time period. And then I think it's around here, like in 1990, that there's a proposal on backpropagation. And just that during 1990 to 2000, there are a lot of papers that use ANN, right? Back then it's called ANN, artificial neural network, combining backpropagation with feed-forward network at that time, during that time. Hinton also published the work around this year, 1997. I think it is in the reference as well, the link as well. Professor Yalikan also published in here, at CNN around 2000. And RBM around 2007, again. Then we have like the revolution of deep learning by the ImageNet competition. I think that there are two competitions back then that have been discussed quite a lot, right? ImageNet and Netflix challenge. And the Netflix challenge is one of the things that lead to machine learning adoption by business. Okay? It offers, like, if you can improve 10% of the accuracy, it will offer $1 million, some sort of that. And people apply technique by a lot of them to solve that, right? AlexNet, and then you have ResNet and deep learning. And then we have Transformer in 2017, and then GPT later on, 2020, and till now, ChatGPT, until now, there are a lot of auto architecture that come along. Okay, so let's look at the generative one. The first one, you can think about it as the RBM. This is, you can think, well, I'm not sure whether I should call RBM generative model or not. It's recommender engine thinking. Like, you have movie layer here, right? The layer here represents movie, and the upper part represents latent variable. And then the down here represents latent variable, the upper part represents movie. Then you export the machine with a number of data. Then once you give it a pattern, it should predict back, generate back the author pattern in the same theme. Right, so it's basically a recommender engine. This results in the RBM results in 2024 Nobel Prize, and that's one for Professor Hinton. And also in 2011, this is the original work by Professor Hinton as well on the autoencoder. Right, so I think these two would be like the earlier version of generative model in the deep learning sense. Before that, you have like sampling technique and so on. You can click the link here down here to see the full papers. GAN start on 2014. About that, I think that was also the year that I started working on big data. Right, I started working on big data, Hadoop, and Spark, Mimi. Right, starting work on that around 2014. And that time here, that's the generative accelerator, GAN, at that year. I remember, I think 2015, I talked to my friend. Back then, he worked at, what's the company though? Sanuk.com, right, back then. It's a very old company. Later, it becomes Tencent. Right? Tencent took over sometime. And then, yeah, so he worked over there. He's also CPE graduate. I asked him back then what types of model that he is working on. He's working on with that. He said he worked on GAN. I think that's what 2015, 16, or that. GAN, that earlier day GAN can be, I think there is like the general multimodal model regression like that as well. But here GAN would be generative adversarial net. And this was the work published by Professor Goodfellow. He then published a very good book on deep learning and reinforcement learning. You can look them up, very expensive. I think the library should have some copies of this. So the idea of GAN here, the picture down here show the adaptation of distribution, and the above show like the architecture and the result that can be produced by the paper. So these are quite good back then, in 2014, that you can produce the image out. At around those years, I think I also started teaching deep learning, but on the deep learning wise, right, to use in classification, reduction mostly. Okay. Then this is like original paper of VAE, like Kingma and Welling, 2013, and Bengio in 2013 as well. Bengio also later published. I think he's also one that who received the Elizabeth Medal, right? Acknowledgement on computing, just like Professor Hinton and Leakin. So this is the work about latent variable model. That is, you can represent the distribution and do arithmetic with them. Okay, once you have like latent distribution. Okay, for VAE, you can like separate them into modes inside there. These are like the original papers. And then here we have autoregressive, right? Well, you can see the evolution of the model, right? From earlier RBM, and then the autoencoder, then generative adversarial net 14. And this is 13 though, by Kingma, Welling, and Bengio. Then autoregressive model transformer and GPT come along in, actually RNN generation has been discussed in Mikolov. It has been done before then, but has been published and quite popularized by Mikolov paper. And also I think he proposed Word2Vec around the time as well. The attention, 2017, by Oswani, right? You have like two part, encoder, decoder part. And then the OpenAI architecture, which use transformer, and then expanded on steroid there. And then later on, we have like the combination multimodal model. The class, the deep learning class that I taught, like used to teach, and I will teach next semester as well. I usually end with this as in the last lecture, like multimodality transfer learning. That you can, this one, it cut like ResNet and combine with, cut ResNet and combine with the language model INN, and then train with a bunch of data, a bunch of caption, so that you can like extract caption from image. And so using those traditional model combined together, you can have like multimodal model. Right? But nowadays, that's history, 2014. Right now, I think this is from Google, right? A bunch of researchers from Google kind of do that, and that's quite, I think, nice example. We will probably try to do that, so it's very good example. You can run it on your own computer to see the result. And then you have stable diffusion by Rombach here, proposal in 2021, and later adopted. And we see nowadays, right? And for now, we have like multimodal, so many of them, multimodal foundation model, like GPT-4, combining text image together. You have stability AI, stable diffusion, connect text to image. We have Sora, like text to video, and many others. Some of these use like temporal model, the time as well, Sora in the video part. Otherwise, it would kind of align between language and visual concept together in here. Okay, so what we have today is also the consideration with how do we deploy the model efficiently, right? And there is like the way that you can deploy it. There are multiple ways. Some would be to do the retrieve the context in the RAG, doing prompt engineering, fine-tune the model, and try to deploy them. And there are plenty of techniques that I try to deal with this, doing the zero-shot learning, meaning you don't have to train the model, or you can use like few-shot learning, using just few time, and then get the result. So there's like a way to fine tune, to deploy, and then collect and improve the model. Okay, I probably move on. We will talk about this later on, right? The technique, improve that. And the improvement cannot be done if we miss some of this development. We have things like Hugging Face, right? That allows us to share the model to everyone, right? Even before this one would be Kaggle, share the data set. This one share the model, share the data set. You can play with it. And then we have here the GitHub that you allow to share the model, share the code, share the idea, and share the whatever hobbies, right, that drive everything out. So combine everything together, you have this rapid development in generative AI. Okay. Use case, you probably have seen this, but some of these has been like adaptation from the original computer vision. You can use Gen AI to do image synthesis for sure, editing, and doing something cool like super resolution, increase resolution of the data, generate data in more detail. Text generation for text, summarization out, synthesize voice, clone, generate music for audio, and multimodal, combine everything together, right? Can use it to perform data augmentation as well. Augment data and perform scientific simulation. And in industry, you can see use case that use multimodal and normal model to do different kind of thing. Okay, right now, this has been like hypothesized for a lot, like it will replace us, right? AI is coming, it will replace everyone, right? It does replace some skill. It doesn't really replace human. So it does replace some of us, just like computer. Before the computers, there is a skill called typewriting. Everyone that want to work with computer has to learn typewriting. That skill is already kind of obsolete. Right? There's no typewriter anymore. But it's nice to still have the skill, right? It replaces some of the job, but it also those jobs has been replaced with some other job to do other things. Right? So you ask me whether it will replace everyone here. Well, human has a lot of fidelity. A lot of things that cannot be yet be represented by computers. So it probably replaced some of the automated tasks, for sure. But will it replace coder? Not anytime soon. Or even for system admin, I don't think I would trust my system to deploy with generative AI yet, though. But well, because there are certain decisions that has to be adapted, and those of you have out there that learn reinforcement learning, you know that learning policy is not easy to have like policy to make decisions. Generative AI as well, right now, it remembers everything as patterns in the model. And people hype that it has intelligence. But what is really intelligence, right? That is it just an ability to generate sentence or ability to like latent model separate patterns or something else, right? Something else that combine, synthesize things together. And there are also other misuse as well. I think that when you talk, well, I just example that would not offend anyone would be to use Trump pictures. Will not offend anyone, right? So deepfake, right? There's a problem with that, and combining with the scam and the threat in the cyber crimes that really create a lot of problems. One of the, I think you may notice it that the AI era coming in will not enhance only us, but it will also enhance the dark side of society as well. Right? So we have seen that on the internet already, and it will come in terms of the threat in the criminal world as well to use this. Well, and we have like, although the commercial model are able to prohibit that to a certain extent, but there are open source model which anyone can use. That means they can also use that. Right? Hallucination, right? Okay, you know what that is. You use the ChatGPT and others, and also IP issues. I'm not sure if you have seen this. Very cute, but that's the IP issues. Just look at that. It's Pikachu, private Pikachu, right? Saving private Pikachu. So you can just look at the link and then see there. All right, so the course here will be about partly theoretical, partly implementation, and partly applications. Okay, that means it will not really take the state-of-the-art model and play with the state-of-the-art model. Right? If you want to do that in the project, it's fine. But the core courses will not focus on that. You focus on the foundation, as you can see in the GAN, in the VAE, in the diffusion model, know the concept, how to build them, right? And that would be like the core theme of the course. So I would just leave you with the last question though. When you look at this, like we talk about generative AI, right? But when we talk about model in general, what makes the model generative? When do we call something generative? When we work with the program. Can you use if else and have generative model? Why not? And what is generative, right? Can if else do the work? If else and generate pattern? How about random generator? Random number generator. Is that a generative model? It generates number. Statistics world, you can sampling probability distribution and get number out all the time. Generative model. I want to think about that. When would you call a model generative? Right? The statistic one, yes, it is generative. Because when you're sampling, you produce something, right, out of the representation, but really simplistic one. So generative model doesn't have to be ChatGPT. It can produce choice, yes, no, automatically. It can produce data in lower rate as well. It can sampling from binomial distribution, from joint distribution, from machine learning. Right? So what makes model generative? Right? Workflow, right? Like the input should be some certain condition and now some black box process, and the output should be like sampling by the condition that we. Right. There are certain keywords like the keyword sampling. Now think about sampling. What makes sampling part of this generative model? Why is that, right? And if you understand this, you know that there are actually a lot more than what I described here that can be generative model. Random choice can be generative model. Right? I think you have already done that in CPE 100 in the basic programming, right? That take random generator And if it's more than certain value, then yes, that's yes. And if it's go the other way around, then that's no. Then use that to play game some sort, right? That's generative or not, right? So I leave that as the question for today, for you to think about that more. Um, after this, uh, we will cover in the next week. It will be on PyTorch introduction, and then move on to the topics here. You can see the date here. We will try to fix with the schedule as we have here. Otherwise, if I fail to come at any time here, we'll probably have to combine it a bit. But at least for the whole content, it should be about, say, 10 times that we can cover the whole topics here. Okay, so that would be all. If you want to have, I think the book is by Mark Liu. You can search GitHub, generative AI using PyTorch, I think. Generative AI using PyTorch. There's the GitHub there. You can clone the GitHub. And then some of the notebook will be from there, but I will add on like exercise and lab that you have to do on your own. Book does contain enough math though. We will have to add more from the source to that. Okay. Usually for each of these, there will only be like 1 hour lecture, approximately 1.5 hour lectures. Then you can doing the lab and finish everything within say 2 hours, 2.5 hours. And you don't have to do homework, right? So you can finish everything here in the class. Otherwise, you can take the work home and then submit it before, say, the subsequent week. Right? That can be done as well. Anything I missed here that you want to add in? I think it's already too many. Well, it's a little bit rushed here. I think actually before the sequence model to transformer, there are like earlier model that use encoder decoder style. But we don't have enough time, so we probably just gonna jump to the transformer which combine everything already in that. Right, that's it. Okay, join the Facebook group. I will post the video onto the group. Once I got the video from that. Really? Let me check. The link is not broken, but I will probably have to set the privacy setting. Right now it should. Let me check. I think it's the group setting. Oh, it's private right now. I need to change it to. It's in confidential to change it public. You can manage. Who can join the group? Only profile and page. Well, it changed. So let me figure it out somehow. Who can approve member? Yeah, it's profile already. Can you see the group now? Okay. Let me figure out the automatic join. Admin assist. Approve member if you know PL. No. If there is friend, at least one friend in the group. All right. So you should be able to find the group now. I'm going to upload the video here and also the slide. Actually, the slide should be in LB too, but I'm going to upload it anyway to the group. Okay, and these are all. So these are all for the online as well. You can join the group right now, and then I'm going to upload the video afterward, after I see the video first. And see you again next week then. Um, hopefully, hopefully you can decide now whether this is suitable or not, right? from the content and the grading and everything else. Will there be quite a lot of work? If you do the work in the class, probably no, because you can finish everything in the class in terms of working with your group. But at the end, you still have the project that you have to talk to your friend on what you want to do that, and that is quite a lot. Um, so I would say the load would be quite moderate, right, for this course, and we have only one exam at the end. Okay, I think that should be all, and thank you for coming. See you again next time. We will cover the review of PyTorch for the next time.